Hello guys, in this video we will be looking into how to add node into a linked list at a very particular position. In the last video we have discussed about the basics of linked list and how to add a node at the last of the linked list. If you haven't looked into that video, or if you have any doubt with what actually linked list is, please do refer to that video. I'll be giving you a card on top of this video and you can have a look at that. Alright, so let's get into the video. So initially since you already know what linked list is, I'm just gonna draw a linked list which has like around 3 nodes, let's say. Alright, so as you all know, the very last nodes next will always be null. Only if it is null we can call that as the very last node. Alright, and the first node will be called as head, and let's say it has some values like 8, 10, and then 12. Alright, so let's assume this is your first node, second node, and it's your third node. So here first node will be containing the address of the second node, and second node will be containing the address of the third node, and so we have got these kind of links. Alright, okay, so let's say that I want to insert because in the last video we just looked at like just to add, and we'll not be giving the position like where to add, but this time what we are going to do is like we'll be giving a data. Let's suppose I want to add 11 at the position 2, let's say position 2, in the sense like you can consider anything, like sometimes people consider this as a second node or maybe second position, just like the index value, because index value always starts from 0, right? So if this is 0 and this is 1, they want us to insert 11 at the index 2, which means in between these two guys, that is like in between 10 and 12. All right, so how are we going to do that? Because all we know is just a head, because like in any linked list, whenever you looked into a data, whatever the linked list, like whenever you're creating a linked list, the only data you'll be having is the head of the linked list. So even if you want to add something or delete something, the only possible way is to iterate through each and every node. All right. So here, what are we going to do? What are we supposed to do? See here, from the first node, since we know the head node, let's have something called as current node, because this is the one who is going to hold the current node. In the last video I have mentioned that this is the one who jumps from one node to the other node until the very last node, but here also we are going to do something similar to that, but not until the last node, but until this particular index. All right, so as for now we are setting our current to head. So as for now it is like current is equal to head. So current is a variable who's holding the head. So when are we supposed to stop it? So in order to insert something in between these two nodes, what we have to do is like we have to jump until this node. Your current should be pointing at this particular node. I mean, like I'm talking about this node, the second node. All right, because you wanted to insert a particular node at the third position, right? Since I was talking about the index value, this is 0 and this is 1, and this will be this was your 2, and you wanted this node, this 11, to be your 2, so it has to be in between these two guys. All right, so from here your current is going to jump to this particular position. So how many jumps should I make? All right, so since it is 2 node, I have to make 2 minus 1 jump, which means if I want to insert a 3, then 3 minus 1, which means 2 jumps has to be made. So here, since the number of iteration is known, we can use a for loop. It's very much simple, right? Last time we used a while loop because we don't know how many nodes we have, like which will be the last node. It might be like a four nodes or 11 nodes, whatsoever, we don't know that. But here we already know that we are going to insert at this particular position, so we can jump for this many number of times. That is where you're supposed to insert -1. I'll tell you why is it -1. We are going to insert in between 10 and 12 only if you stop your current node at it'll be good if I change the color. Good. Only if I stop the current node at this particular position, I can say this node dot next is the upcoming node, which is the one which you are about to insert. All right, and also we should make I think it's kind of messy, so I can clear something, you'll understand in a better way. All right, so as for now, your current, as I told you, you're going to shift your current until this node, that is this node. Your current is now focusing on the second node. I'll tell you why. Only if you're going to stop it here, you can make, what we actually have to do is like cut off this address, because now node 2 is holding the address of node 3. So what you have to do is, node 2 is supposed to hold the newly created node, that is actually 11. All right, 11, and obviously whenever you're creating a node it will be null, as I told you. All right, so forget about this one. So as for now, 2 should point out to the new node, and the new node's next has to point to the third node. So this is how it has to be made. All right, so in order to do that, we have to stop one step before, and that's the reason we are making our current stop at position 2, that is your second node. All right, so now it's very easy. So now you know very well that your current is pointing to this node, so you can simply say that current dot next, actually current dot next is nothing but 3, but now we are going to update it. It's not 3 anymore. But you should know one thing. See, who knows where 3 is? 2 is the only guy who knows where 3 is. 2 is the only guy who has the address of 3. So if you are directly putting like current dot next is equal to the newly created node whatsoever, let's say like you're going to create the new node in a variable called temp is equal to new node which you're going to create, and then you're putting current dot next is equal to temp. You can do this, but you have to keep one thing in your mind: the address of 3 will be lost. All right, this one, the 12, the node which contains 12 will be lost, because 2 is the only guy who knows where 3 is. All right, so if you directly put the 2 dot next, which is your current dot next, is equal to the new node, you will never be able to make this point, the new node dot next is equal to 3, because no one know where 3 is, right? So what you have to do is, like, as a precautionary moment, what you have to do is this 3, as for now this 3 is nothing but 2 dot next, that is your current dot next. Clear? Because you already have, I mean, like, as for now you have this line. All right, we still didn't discontinue this particular line, so we still have this one. What are we going to do? We are going to have a temporary variable. All right, temporary variable, let's say t is equal to current dot next. We didn't execute this line, don't get confused, we didn't execute this line. All right, so your current is your 2, so we are storing current dot next in t, which is nothing but 3. So we are storing the address of 3 in a temporary node called t. All right, so now t, this guy knows where 3 is. Now we can boldly delete the address of 3. Now what are we going to do? We are going to make this connection, this 2 to new node. So we can say, now we can execute this line, the one which I have struck out. Current dot next is equal to 10. That way this one will be created. So 2 will be now pointing out to the new node. Alright, so we are not done actually, because we have to do one more step. The other step is the new node should point to the, because we are inserting the new node in between the earlier 2 and 3. Alright, so this new node dot next has to point to the node 3. That is also mandatory. So how are we going to do that? We know very well new node is at which position? It already has a variable. Here it is. Temp is a variable who is holding the new node. So we can easily say that temp dot next represent this area, the new node's next. So new node whose address, like a new node has to hold some address, right? So we are going to tell like which address you are supposed to hold. So we are telling temp dot next is equal to, temp dot next is equal to, that is this particular position, we are going to fill this position, is equal to t. What is actually t? Earlier, you remember earlier we stored this 3 somewhere. Alright, the address of 3 in a particular variable called t, right? So that is what we are going to put here. So temp dot next is equal to t. This way you are making this link, the link between the new node and third node. So now if someone who has the head, if they are going to iterate, it will be like, this will be your first node, this will be your second node. Let me change the color so that you can understand. This is your first node, this is your second node, and this is your third node, and then this will be your fourth node. This is a this is a way where we can insert node at a particular position. So we can look into the code as well for this particular problem. All right, so here is a code which I have written for inserting a node at particular position. So this is a value, this is a position where we are supposed to insert the node. So let's say you already have 20. Let's frame the same thing what we did in the last video. So 20 comma the address of second node. So this is actually your head and also your first node. So this one, what I'm giving here is just for you to understand in a better way. Doesn't mean every node, the very first node's address will be one. It will be actual address. All right. So for you to understand in a easy way, I'm giving 1, 2, something like that. All right. So this is like 30, 3, and you also have 40, 4. All right. So we have already got links for all these guys. All right, let's not have, okay, let it be like 60. All right, so this is node 2, this is 3. Okay, cool. So what I'm going to do is like I'm just going to add data 40 at the index 3 or maybe 2. Sometimes, like if you're going to consider index value, it's up to you to design the work. It's not something which is mandatory. Okay, so if you're going to consider that as a position, you can have one step down, and here it's not less than 10, it is less than index minus. All right. All right. So as I said, like current is a variable who is going to hold the head, the very first node, which is nothing but this node. And then I'm making this for loop in such a way that it iterates for index minus 1. If the index is 3, let's say 3 in the sense like I want to insert at this position, that like this position, which means like in between 2 and 3. At this position, what I have to do is like I have to make this jump for one time. All right, that is less than the index time. I mean like index, like because what I'm doing here is like I'm considering this as the index value. So when I say 2, it represents this particular position. Wait, I'll give the input here. I want to insert 40, and then at second position in the sense like this is 0th position, this is first position, and second position, this is actual, as for now this is the second position, but we are going to insert 40 at the second position, so in between these two guys. All right, so what I'm going to do here, index minus 1, index is actually 2, so I 0 less than 2 minus 1, that is actually just one iteration. All right, one iteration. So this particular jump will be made only once. Actually your current is holding here, holding the head, so that's here. If you make one jump, your current will be focusing here. All right, so your current will be focusing here. As I told you, if you want to insert something at a particular position, you have to place your current one step before. So that's what I did. So after coming out of this for loop, your current will be focusing this node. So as for now, current.next is holding 3, the address of 3. So what am I doing first? As I told you, you have to store the current.next, that is like the address of this guy, so that you can change this value, because 2 is the only guy who knows the address of 3. So if you're going to alter this particular position, this 3 will be often like no one will ever know where this guy is. So you should make someone to store the address of this guy. So that's the reason I'm making the temp variable to hold the address of current.next. Current.next is nothing but this guy 3. All right, so this guy will be holding the address of 3, that is temp. Then what am I doing? Current dot next is equal to new node. I'm making the new node here. When I was explaining there, I just created t, right? Here I'm not making any variable. Directly I'm making a new node with the data whatever the user is providing. So current dot next, that is this position, is equal to the node which you are making. All right, whatever the node which you are making, that address will be stored here. So the address of new node will be here. So this connection is no more. So this connection is actually to the new node 40, and as for now it is null. All right, because like for the new node we haven't told the new node to hold the address of 3. I mean the earlier 3, which means like as for now this is the last node. So we haven't told the very new node which has we just inserted to hold the address of the very last node, that is 60. So that will be done in the next step. What am I doing here? Current dot next dot next. What is that? This is your actual current. Current dot next is your new node. So current dot next, this will be substituted by new node. All right, because the new node is a current dot next, right? So if you substitute new node here, you can read this as new node dot next. So that is new node, not this is actually your new node dot next, which represent this place, is equal to temp. What is actually temp? Temp is the guy who is holding 3. All right, that is this guy. All right, this shifted, okay, that is this guy. So this guy will now hold this 3. So now the linkage between these two guys is made. All right. Okay. So this is how you create these things. And one more thing you need to do is like look at the next of this guy. This guy is next, actually 3 dot next. It's not 4 actually. It's supposed to hold null. You have to reset that to null. Resetting this to null is nothing but okay. We are making this because temp dot null. What is temp? Actually temp is this guy, right? So we are making this to null because this guy is the very last node and it has to be null. This is the reason we are making this one. Alright, so we are done with the adding stuff into a particular position. So whatever the data user is providing, that, and also along with that they'll be giving you the position, and we are adding that in that particular position. So that's all about that. And next we are looking into the delete function. So what is delete function? Just like that, and we will get back to the whiteboard. Here it is. All right, the same thing. Oh. All right, so here is your node. Let's say node 1, node 2, and again node 3. So you have the values like 3, 4, and 5, and that's the linkage between these guys like this. Okay, let's say you want to delete this node. The user is providing as 1. Let's say this is 0 and this is 1 and this is 2. So what we have to do, the only thing we have to do is like this guy, the first node, the very first node, that is your head, is actually since I'm going to delete the second node, I'm talking about head, because like what you have to do is like the node where we are going to delete, you have to stop, just like your previous problem. You have to iterate and stop right before the node which you're about to delete. So I'm going to delete this node, and that's the reason I'm making my current focus on this one. Else, let's say you want to delete, you have one more node. Let's say you have like 7 here, you have, and the index value is 3, and if you want to delete this node, what you have to do is like initially just using your for loop, just like the previous function, you have to use your for loop to place your current right before the node which you're about to delete. I'm going to delete this 2. Alright, so I'm making my current to be here. Alright, so it will be keep jumping until it reach this point using a for loop. Alright, now what am I going to do? The only thing I have to do is like this node, this node 1 is pointing to 2, and 2 is pointing to 3. So what I have to do is like in order to delete 2, I just need to tell 1 to hold the address of 3. That is the only thing I need to do. Obviously for say look at this one, where when someone is going to iterate this linked list using head will tell my next node is this guy will tell the next node is this guy, and obviously this node will be skipped. This is lost. Alright, so that's the only thing you need to do. So that is what we are going to do there. Alright, so let's get into the code. If you understand the previous one, because like I'm not explaining this in a very detailed way, because the previous one I told you inch by inch, so you understood a lot. This is just like a same process. So if you don't understand this one, if you feel like this is too short, look at the previous function, that function at a particular position, that will give you a very clear explanation. So let's get back to the code. Here we are. Alright, so look at the return type. Like what am I doing is like, sometimes what if the user wants to delete a particular guy who is out of index, which means you already have only 3 nodes, and user wants to delete the node at 10th position. You already have just 3 nodes, and how am I going to delete the 10th position? No way, right? So I just made this function little interesting, stating that like if I have successfully deleted the node which the user says, I'll be returning 1. Alright, and if the user, oh I'm sorry, okay, if I couldn't delete the node which the user says, which means like if it is like out of the index, or it's not about the index, because linked list is not about the index, but let's say like linked list has only 5 nodes, and I'm trying to delete the 6th node or 7th or something which is not actually there, then I'll be returning -1, which is like it's not successful. So if someone calling this method, and if they are receiving -1, which means the delete function is not successful. Alright, so I is equal to 0. Here the same thing, I'm doing the same thing. Just skip this part as for now, just skip this part, and what I'm doing here is just like the previous function. I'm just skipping the I'm like just jumping from one node to the other until the node until the node previous to the prior to the what is that, like the node which you are about to delete. All right. So this one, what am I doing here? When you're jumping, wait, I'll copy this and paste it here. It'll be easy for you. Okay, so earlier your C was here, and you keep jumping from one node to the other node. Let's say this is the node which you want to delete, so your current has to jump from one node to the other until this node, right? One step before the node which you're about to delete. Let's say here all you have is like 1, 2, 3 and 4. Let's say you want to delete 7th node. User by mistake he has given 7 here, and your for loop says go until index minus 1, so it will go until index minus 1, which is 6. So j less than 6, so it will have 5 iterations. 0 to 5 it will be 5 iteration. So 5 times if you are skipping, after one jump C will be here, and after next jump C will be here, 2 jumps. After third jump, in your fourth jump actually C will be holding to null, that is last node dot next null, and in the fifth jump your C will be actually talking about null dot next, which is not there actually, because null is actually nothing. All right, only if you have node you can talk about this node dot next. When it comes to null, obviously there is no next, so you'll be getting null pointer exception because you are trying to delete something which is not available. So that's the reason what I'm doing is like when I reach this point, when current is equal to null, current shouldn't be equal to null. All right, so when my current is null, I can tell my user that this process is not successful, so it's something weird you're asking for. All right, and if this condition is not satisfied, it's just like your previous problem, you keep shifting your current one step before the node where you're going to delete. All right, then after coming out of the for loop, and as I told you, you're going to delete this node, that is your third node, so I'll be stopping your current at this point. So there's node 1, node 2, node 3 and node 4. Okay, and your current is now at node 2. Okay, all right, and this is holding actually node 3, this is actually holding node 4. All right, so now look at this line carefully. Current dot next, who is your current actually? This guy is your current, who is the node 2. So current dot next is equal to, I'm talking about this position. This position is actually holding 3, and we are going to remove 3 in this particular function. So what we have to do is like we have to make 3 in such a way that we have to, we have to make this in such a way that remove this 3, don't hold the address of 3 anymore, rather hold the address of 4. But you know what, this guy doesn't know the address of 4. As I told you, like each and every node will be knowing its very next address. All right, so what we are going to do, we have to seek help from node 3 to get the address of 4. So we can say that this guy is equal to, that current dot next is equal to current dot next. Who is current dot next? That is actually, as for now, current dot next is this guy. So current dot next dot next. So as for now, current dot next is nothing but 3. So 3 dot next, this will be replaced by 3. So 3 dot next, which is nothing but 4. So I'm telling my current node to hold 4 indirectly. So this way, this linkage will be cut off, and then this will be pointing to this linkage. This will be pointing to I don't have the drawing part here, so it's hard to make this. So this will goes off, and the linkage between these two guys will be made. All right, so this is how we delete a particular node at a particular position, because if you want to delete something, there's also some function like delete, and it won't take any parameter, which means the user will not give any position, the position from which the node has to be deleted, but they will just call the delete function. That time you have to iterate your current to the second last node, so that from there you can remove the very last node. Alright, because if the user is not giving any position, you have to remove the last node, just like your add function, because when user don't give the position, you'll be adding the node at the last, right? And also you can remove something from the beginning and you can add something at the beginning, but adding something at the beginning or deleting at the last, or deleting something from the beginning and deleting something from the last, these things are pretty simple, alright, when comparing to functions like this. Alright, so that's all about linked list. Like in the previous video I just spoke about how to add, and also about the basic, like how to what is linked list and what are the things, like a detailed explanation about what linked list is. Because if you don't know what linked list is, like, you have to definitely watch my previous video, and I'll give a card on top of this video again. So if you don't watch that, you please watch that, and you'll get a better understanding of what linked list is. Then if you're looking into this video, it will be very much clear for you. All right, so that's all for today. Thank you for watching this video. If you like my channel, please do subscribe, and if you like this video, please do give a thumbs up and share it to your friends. Thank you.